In this video, we're going to price bonds using a technique called bootstrapping. In the last video lecture, we looked at how to price treasury bonds using strips. Unfortunately, strips are not available at all maturities, so we have to find an alternative way to price bonds. We're going to do that with bootstrapping. The goal of this video is to price the 3% 757-day note. This is the same note that we valued using strips in the last video. Here we have the timeline for the interest payments and the principal repayment on this note. What information do we need though to price this note? We need discount factors. We need to know how to bring all these cash flows back to the present day. How many discount factors will we need? Well, we're going to need a discount factor to bring back the cash flow at day 27 to the present day. We'll need one for day 208, for day 392, for day 573, and day 757. What we're going to do to calculate the discount factors is use the prices of other notes and bonds issued by the US government. Because we need 5 discount factors, we're going to need 5 different bonds. And we're going to need to find notes or bonds that mature at all the different times that we need discount factors for. So we need to find a 27-day discount factor. For that discount factor, we need to find a note or bond that matures in 27 days. For the 392-day discount factor, we need to find a note or bond that matures in 392 days. And the same for all the other days where we need discount factors. And here we have 5 different notes that mature on each of the days when we receive payments from our bond. All these quotes are taken from the Wall Street Journal, and we're going to use this information to calculate discount factors. Whenever we use bootstrapping, we first have to calculate the discount factors with the shortest maturity, and then work our way towards the discount factors at longer maturities. Let's start with the 27-day discount factor then. To calculate the discount factor, we first need to convert the quoted price into decimals, and the quoted price was 100.03. That's in 30 seconds. When we convert it, 3 divided by 32 is equal to 0.09375. So the price in decimals is 100.09375. In dollars, that's going to be $1,000.9375 if the par value is $1,000. Now what's the price today equal to? The price of this note is going to be equal to the present value of the coupon payments plus the principal minus any accrued interest. Why are we subtracting accrued interest? Well, remember, the Wall Street Journal quotes are clean prices. That means we have subtracted the accrued interest. We know that the coupon is 5.625%. That means in dollar terms, if the face value is $1,000, the coupon payment is going to be equal to $56.25. But coupons are paid semi-annually with government notes. So the payment that we're going to receive in terms of coupon in 27 days is 28.125. Now we've got to worry about accrued interest. We own the bond for 27 days out of the 184 days since the previous coupon. The accrued interest is going to be over the previous 157 days. Now let's see if we can calculate the discount factor. We know that the price today, 1,000.9375, is equal to the present value of the coupon plus the principal minus the accrued interest. Well, the principal is easy. That's going to be $1,000. Plus, well, how much do we get of the coupon payment? We're going to get 27 days divided by the 184 times by the coupon payment, 28,125. We can simplify this. The price today is equal to the present value of $1,004.127. How do we calculate the discount factor? The discount factor has to equate the price today with the future cash flows. The price today has to equal the discount factor for 27 days times by the future cash flows that we will receive, which is 1004.127. If we divide both sides by 1004.127, we get the discount factor for 27 days, which is equal to 0.99682. That's the 27-day discount factor. Now let's try and calculate the 208-day discount factor. Again, we have a note for 208 days, and the price of that note is 98.84375 when we convert to decimals. In dollars, we're looking at a price of $988.4375. Again, we know the price today is going to be the present value of the coupons plus the principal minus any accrued interest. The coupon payment is going to be $23.75, but it's paid semi-annually as with all government notes and bonds. So the payment that's going to be received every 6 months is $11.875. Once again, we have to deal with accrued interest because we only own the bond for 27 of the 184 days before the next coupon payment. That means the price today, $988.4375, is equal to the discount factor for 27 days times by, what do we receive in 27 days? Well, we're going to receive some of that coupon payment after we've subtracted the accrued interest. So that's what we're doing here, calculating the fraction we receive. This is what happens in 27 days, but we also then have to think about what happens in 208 days. And we have a discount factor for 208 days times by the cash flows that we receive then. And we're going to receive par value of 1,000 plus the coupon payment. We already know the discount factor for 27 days. We calculated that earlier. Let's substitute in that information. The discount factor was equal to 0.99682 times by 27 over 184 times by 11.875 plus the discount factor for 208 days times by the cash flows in 208 days. You can see now the only thing we don't know is the discount factor in 208 days, and we can do some mathematics to calculate that discount factor. Let's simplify the problem. Now what we're going to do is subtract 1.7370 from both sides and then divide through by 1011.875. So the discount factor for 208 days is going to be equal to 988.4375 minus 1.7370, all divided by 1011.875, which equals 0.97682. 0.951. That's the discount factor for 208 days. We can use the same technique used to calculate the 27-day discount factor and the 208-day discount factor to calculate discount factors at 392 days. So exactly the same approach. We do the same for 573 days. And we can do the same for 757 days. The result is that we've used 5 government notes or bonds to calculate 5 discount factors. We can now use these discount factors to price the 3% note that matures in 757 days. All we need to do is calculate the present value of the future cash flows. And we know that at 27 days we're going to receive $15, but we know that there's accrued interest there. So if we want to calculate the clean price, we're going to do the discount factor for 27 days times by how long we own the bond for, which is 27 out of 184 days, times by the coupon payment, which is 15, plus the discount factor for 208 days, which is 0.9751, times by the coupon, plus the discount factor for 392 days, which is 0.9538, times by the coupon of 15, plus the discount factor for 573 days, which is 0.9342, times by the coupon of 15, plus the discount factor for 757 days, which is 0.9149, times by, well, here we get the principal and the coupon, so 1015. And if we do this calculation, I get $973.764. That's the present value of the 3% note maturing in 757 days, after accounting for the accrued interest. What do we need to get the quote? To get the quote, first of all, we need to put this in percentage terms. So as a percent of $1,000, it's going to be 97.3764%. We've now got to convert this decimal into 30 seconds. So we're going to do 0.3764 times by 32, which is approximately equal to 12. The quote that we would see in the Wall Street Journal would be 97.12. That's bootstrapping. We have just priced this note using bootstrapping. Now let's compare our valuation approaches. In the last video we used strips. In this video we've used bootstrapping. And we've calculated prices using both approaches. The Wall Street Journal said the price was $97.11. Using strips we find the price is $97.13. And using bootstrapping we find the price is $97.12. In theory, the prices should all be the same. And that would mean that the discount factors should all be identical. In fact, the discount factors aren't quite identical. If we look in each period, they're not the same. They're close, but not identical. Remember we talked about transaction costs. This may account for some of the differences. But these discount factors are identical to 3 decimal places, and we will see that the prices that result are very close to the Wall Street Journal price. The discrepancies between the prices and that quoted in the Wall Street Journal arise because of the market frictions. Remember, we have to deal with bid and ask prices. We also have to pay commissions fees to brokers. All these frictions will mean prices will be slightly different using strips, using bootstrapping, compared to the Wall Street Journal price. You could use the strip approach or the bootstrapping approach to identify arbitrage opportunities. But you have to take into account transaction costs. The prices that we're seeing here suggest there are no arbitrage opportunities when we compare to this price that's quoted in the Wall Street Journal. But we have computers every day that are looking at all the bonds that are out there, all the government bonds, and trying to identify mispricings that, even after taking into account transaction costs, can be exploited to make money. The fact that we have computer programs that are constantly searching for these mispricings mean that as soon as a mispricing occurs, it's very quickly eliminated via an arbitrage trade. That means that the prices we see are going to be very close to their true values all the time. It's going to be very hard to find arbitrage opportunities in the US government bond markets. What happens if we're trying to value non-government bonds? The strip pricing and the bootstrapping methods are there for treasury notes and bonds, but there's no default risk with treasury notes and bonds. With corporate bonds, we've got default risk. If we use discount factors that contain no default risk, then we're going to get mispriced corporate bonds. So do you think the corporate bonds will be overvalued or undervalued if we use these discount factors based on government bonds where there's no default risk? If there's default risk, you'd think you'd require higher rates of return. In other words, your discount rates will be higher, which would mean your discount factors would be lower. So if we use these government discount factors, the corporate bonds are going to be overvalued. We need to lower the discount factors to reflect credit risk. How much you lower these discount factors is a complicated problem. We're not going to cover that in this class. If this is something that interests you, the pricing of credit risk, then you should be taking the fixed income class here. That's all I wanted to cover in this video lecture. We have now seen how to price government bonds using strips or using bootstrapping. See you in class.